Good morning, young learners. Let's try to do one numerical problem, and I believe that it will also help you understand the concepts, the basic concepts, and the theories behind solving this numerical problem. We have taken now this question from chapter number 2, the structure of atom, of NCERT textbook of chemistry of class 11. The question says that how much energy is required to ionize a hydrogen atom if the electron occupies is equal to 5 orbit. The electron is in the fifth orbit in hydrogen atom. There are many possible orbits. So the first orbit, the second orbit, the third, fourth, and the fifth orbit, which also defines the principal quantum number and its principal quantum. The principal quantum number, the term principal quantum number was also used by Bohr, by Niels Bohr, who got the Nobel Prize in Physics in 1913 for explaining the hydrogen atom. Compare your answer with the ionization enthalpy of hydrogen atom. What is ionization enthalpy? It's the energy required to remove the electron from n equal to 1 orbit, or the electron in the first orbit. That's ionization enthalpy. You just need to compare what is the difference, what is the ratio of the energy required to remove the electron from the first orbit and from the fifth orbit, right? So in order to know to proceed with this with the solution of this problem, it's related to, I need to tell it, it's related to Niels Bohr's postulate of hydrogen atom, and not to the postulates. It relates to the theory of the hydrogen atom, how it explains how the hydrogen atom is stable. What are the energy? What are the position of the radius in which the electrons revolve in various orbits? The orbits, the stationary states, the energy in them, the frequency of the light that will be emitted or absorbed when electrons jump from one orbit to another. So these are the things that he had explained, and how the spectrum, hydrogen spectrum, is formed, how it is related to the electrons and their jumping from one orbit to another. So in his the second point in the theory of hydrogen atom, the Bohr says that the energy of the electron in any orbit, in the nth orbit, or he says that he uses the term stationary state, which is in complete like it's in fighting mode with James Maxwell, who said that when any charged particles, when they accelerate, when their velocity increases or decreases, there will be release of electromagnetic radiation or energy, and because of that, Rutherford model was not able to explain how the atom is stable, even though electrons are, so because he said the electrons are revolving. So that revolving is what it is having. Its velocity is changing, not in magnitude but in direction. So there's an acceleration. So the electromagnetic radiation will be emitted. Also, the energy will reduce, and now then the electron will move around, and it will just submerge inside the nucleus. So he was, and that means Rutherford was not able to counter the Maxwell theory of the electromagnetic radiation. But here, Bohr says that as long as the electrons are in the stationary orbit, that means which are allowed orbits, having allowed radius, or having allowed energy, or having allowed angular momentum, they will not release any energy. Energy is released or absorbed only when electrons are moved or transferred from a lower orbit to the higher orbit, or from a higher orbit to a lower orbit, right? So whenever they are in any orbit and then they are revolving around it, they won't release any energy. They are stable. That's what they said. That's what Bohr is saying, the stationary state. As long as the electrons are in allowed stationary state, they will not emit any energy or absorb any energy. Fine? Sorry, they will not emit any energy. So the energy in the nth state, in the nth orbit, En, is given by minus of RH multiplied by 1 by n square, where RH is a constant, convertible constant, and is having value 2.18 into 10 to the power minus 18 joules. Its unit will be same as joule, because this is simply a number, the nth orbit, the principal quantum number. since our atom is lying at the fifth orbit, first, second, third, fifth orbit, right? Fifth orbit is very far away. So the orbit, the radius of the orbit is inversely proportional to n square, to n, right? To n square. So it will vary a lot. The first orbit will here, second will somewhat more, and third will again very far away. It's like that. So the value of n here is 5, where we replace the value by n by 5. 5 squared 25. So it becomes 218 by 25. How I have done this? I remove the point, or I just move the decimal to after up to this point, 2 places. So it's been so necessary changes are made here. So it becomes 2 to the power minus 10 to the power minus 20. So it becomes 218 without any decimals, because it's easy to divide well when there is no decimal. 218 divided 25. How I have done this? I assume that this is 225. This will the only the different 7 numbers, right? So 225 means it's exactly divisible by 9. 100 by 25 is 4, so 200 is 8, then one more 25, that is 9. So it becomes minus 9 into 10 to minus 20 joules. So this is the answer. This is the answer you will find in a textbook, in the back of the textbook. It's 8.779, slightly small, slightly lesser value than 9, because I increased the value here, 225. 7 values I've increased. So and the exact value is little lesser than 9. So it's okay, fine. The approximate value is this much. Now, if the questions wants you to write the value in kilojoules, how will it do? So I wanted to, kilo means what? I wanted to add 10 to the power 3. Somehow I wanted 10 to the power 3 here. So to nullify this, you add 10 to the power minus 3 here. So it becomes 10 to the power minus 23. So it's minus 9 into 10 multiplied by 10 to the power minus 23 kilojoules. This much energy is required. Is required to ionize. Okay, I have not explained the term ionize. What does ionize means? To understand the term ionize, you means you need to understand what is an ion. Ion is a charged species. It may be an atom, or it may be a molecule, a group of atoms together, but having some charge, not neutral, maybe a negative charge or a positive charge, because we assume that an electron has a negative charge, and a proton has an opposite charge of same magnitude as an electron, but of opposite charge. So we assume that a proton has a positive charge and an electron has a negative charge, right? And because of the removal of electron or addition of electron, the species, the atom, the neutral atom or neutral molecule becomes charged, and that is called ion. So what we're doing is we are going to remove the electron from the hydrogen atom, right? It's in the fifth orbit, and we're going to remove it. So when we remove the hydrogen ion, the electron, and the atom will no longer be neutral. It will be because we are removing the negatively charged electron. It will be positively charged species, a hydrogen ion. So the hydrogen atom is ionized. It becomes hydrogen ion H+. So this much energy is required, kilojoules. This much kilojoules of energy is required. This is for 1 electron. If the question is saying that you need to calculate for how much for 1 mole, what will it do? 1 mole means what? Avogadro number. That is 6.022 into 10 to the power 23. So multiply it by it. So it becomes minus 54 kilojoules per mole. I hope this is quite understandable and it's able to understand it. I'm not paying any emphasis on the second part. But if for second part, if n equal to 1, you replace the value of this by 1, then this will be the ionization enthalpy, right? Only this value. It will be in joules, then convert into kilojoules and multiply by Avogadro number. It will be kilojoules per mole, because ionization enthalpy I find in the back of the textbook is given in kilojoules per mole. So you can compare it. How much is the difference? Difference will be what? It's whatever value is this divided by 25 divided by 25 will be. So it will be the value of energy required will be 25 times more when the electron is at nth orbit, in the first orbit. Okay, right? If we need more energy to remove an electron, or when the electron is present in the first orbit, because it is closer to the nucleus, is attracted more to the nucleus, so we'll be needing more energy. But there is one more thing I forgot to explain, is the negative charge that is present. We are Niels Bohr have he has put a negative charge over it. It means that he's assuming that um, uh, when the electron it moves farther from the nucleus, then the value of the numerical value, the absolute value will increase. It will decrease, right? In minus, decreasing means what? -2, then it comes -1. What does it mean? It means that it's bigger value, right? Minus 1 is bigger than -2, more magnitude. Okay, -2 then -1. In first orbit, you're needing minus 2 energy. In second orbit, it will be lesser, -1. That means the electron is having more energy. He's assuming that when the electron is moved farther from the nucleus, it will have less energy in it. Or in other words, it will take less energy to remove the electron when it becomes farther from the nucleus. In fact, when an electron moves so far that it is at infinity, we assume that the electron has zero energy. Zero is again the biggest number. And when we are talking about negative numbers, the number line, zero is the biggest number among the negative numbers, right? So zero, when electron is very far away from the nucleus, so far that there's no influence of the nucleus, it is having zero energy, the maximum energy. So when it becomes closer to the nucleus, it gains it will have lesser energy. Yes, I hope this is understandable. The significance of minus, the minus value in energy.